Hello, and welcome back. I am Sam, your lead tutor. Today, we are stepping away from the wired office and looking at the invisible network that powers the modern world. We are tackling K68, key elements of mobile networks. We all use our phones every day, but for most people, it's just magic. As a network engineer, you need to know how the trick works. We are going to break down the complex acronyms of 4G and 5G, like RAN, EPC, and IMS, into simple, logical building blocks. Mobile connectivity is no longer just for consumers, it is critical business infrastructure. Understanding this allows you to support a remote workforce effectively. Let's use my scaffold and ascend method. Mobile networks are full of confusing acronyms, so let's use an analogy, a parcel delivery service. First, you have the user equipment, or UE. That is your phone or tablet. You are the customer trying to send a parcel, data. Next, you have the RAN, or radio access network. This is your local post office, the cell tower you see on the hill. Its job is to take your parcel wirelessly. Then, there is the EPC, or Evolved Packet Core. This is the massive central sorting hub. It decides if you are allowed to send parcels, security, and where they need to go. Finally, the internet is the destination. The parcel travels from your phone, to the tower, to the core, and out to the world. Let's look at the first hop, the RAN. This is the wireless part. Communicating over free space media, basically fresh air, is hard. You face interference from other electronics and even weather. You also deal with ground bounce and multipath propagation, where signals reflect off buildings and arrive at slightly different times, confusing the receiver. Because the air is public, security is critical. We use strong encryption on the air interface so that someone standing nearby with an antenna can't read your emails. Finally, the RAN handles, handovers. As you drive down the highway, the RAN seamlessly passes your connection from one tower to the next without dropping your call. Once the data hits the tower, it goes to the core, the EPC. This is the brain of the operation. It has 4 key parts you need to know. The MME is the manager. It tracks your location as you roam. It knows which tower you are near. The HSS is the database. It checks your SIM card to see if you are a paying customer. The SGW and PGW are the gateways. They act like routers. The PGW acts as your bridge to the internet. It's the device that actually assigns your phone its IP address. Historically, voice calls and internet data used completely different networks. But now, with 4G and 5G, everything is data. This is where IMS comes in, the IP Multimedia Subsystem. IMS is the framework that allows us to send voice and video over the standard IP network. When you see VoLTE on your phone, that is IMS in action. It handles the complex signaling to set up a call, ensuring the quality is high enough for voice, while still allowing you to browse the web at the same time. How do you use this at work? Imagine your sales team complains that their VPN drops constantly when they are working on the train. You might blame the VPN server, but understanding K68 helps you see the real issue. Trains move fast. This forces the RAN to perform rapid handovers between towers. Tunnels and cuttings cause interference and ground bounce. You realize the issue is the physical limitations of the mobile network causing brief packet loss. You can't move the cell towers, but you can configure your VPN software to be more tolerant of these brief dropouts, increasing the timeout value so the connection stays alive during the handover. Finally, a quick look at the future, 5G. It builds on everything we just learned. The RAN gets faster using higher frequencies. The core, EPC, becomes virtualized, running as software in the cloud, remember NFV? And it introduces network slicing. This allows the operator to create a virtual network just for your self-driving cars that is separate from the network for your Netflix streaming. As a network engineer, you will soon be deploying 5G routers to connect branch offices, so these concepts are vital. For your portfolio, K68 demonstrates your ability to troubleshoot outside the LAN. Use the STAR method. Situation: mobile users reported the corporate inventory app was crashing. Task: I needed to determine if it was a code bug or a network issue. Action: I analyzed the logs and noticed the crashes correlated with users who were roaming between cell towers. I identified that the RAN handovers caused latency spikes that the app couldn't handle. I worked with the developers to increase the app's timeout tolerance. Result: complaints dropped significantly. Reflection: I learned that mobile networks have unique behaviors like handover latency that wired LANs don't, and applications must be designed to cope with this. If you are doing your major project, consider if you are using mobile tech. Are you setting up a 4G backup router? Are you supporting remote workers? If so, include a diagram that shows the path from the user equipment through the RAN to the core. Discuss security. Explain that while the mobile air interface is encrypted, you still implemented a VPN to secure the traffic over the public internet. Justify your choice. I selected a 5G router for the site backup because it offered sufficient bandwidth without the lead time of installing a second physical fiber line. This shows strategic thinking. To conclude, mobile networks aren't magic. They're just a combination of radio technology, RAN, and smart routing, EPC. Remember the flow: phone to tower, tower to core, core to internet. The challenges of interference and roaming are unique to this medium, and as a modern network engineer, your role is to integrate this wireless world seamlessly into your secure corporate network. I challenge you to look at your phone's settings today. Find the APN or access point name. That is the address of the gateway, PGW, your phone is using to talk to the internet. Thank you for your focus, and I will see you in the next session. Thank you so much for joining me today. I hope you now feel more confident in mastering this topic. If you found value in this session, I have a small favor to ask. Please hit that subscribe button, give this video a like, and follow our channel. It really means a lot to me and helps the algorithm show these lessons to other apprentices, just like you, who need support. Don't forget, you can download today's slides and the full transcript at www.mentorinai.com EPA Hub. While you are there, check out our mock interview and portfolio review services to make sure you are fully ready for your EPA. See you in the next video. Keep learning.